As we continue to learn Java programming, we are now on lesson 4, which is about variables and data types. Java programming language is statically typed, which means all variables must be declared first before they can be used. There are two types of data in Java. Number 1 is primitive. This type of variable is stored directly on stack, which means faster access. It is defined by its size and type and represent row value which cannot be null. It stores values. And finally, there are 8 primitive data types and each has an equivalent wrapper class. Number 2, non-primitive or reference type because they refer to object. It describes a concrete type and can have methods which can be called to perform operations. Default value is null. A good example is a string, which is available from Java. Classes and interface are an example too. It stores the handle or address to object, not reference. It's stored in heap memory. How data types are stored in memory? When we declare a primitive integer, for example, int a equals to 10, the raw value is stored directly to the stack memory, as we can see here. While on the other hand, when we define a new instance of string, such as this declaration, string s equals hello, the address of the heap memory where the string hello is stored in the stack memory. That means that accessing the primitive data type is much faster because it's a direct access versus the object reference, which gets the actual value from the heap memory. Here are the primitive data types. As we have mentioned earlier, there are 8 of them, and here we have the column size, the range or value, the wrapper class. This is how we declare these primitive data types, and finally the default value which we can set at the top of the class. Note that these default values will not work inside a constructor or method. We will demonstrate what that means later. Now, looking at the byte, a byte has a 1 byte size and its range is from -128 to 127 positive value, and it has a wrapper class. A wrapper class is an object, and it has an equivalent byte wrapper class. And to declare a byte primitive data type, we declare it like this: byte b equals to 1. We can only set this value from -128 to 127. Otherwise, there will be an error. And short has 2 bytes, and this is the range or value from -32767 to +32767. It has a short wrapper class, and this is how we declare it. Then we have the int, the long, float, double, Boolean, and character. Let's discuss these primitive data types. Number 1, let's look at the numbers. Basically, primitive number data types are divided into 2 groups. Integer, it can store a negative or positive value such as the byte that we have shown earlier. And then we have short, int, and long. So basically, these first 4 primitive data types. If we want to save memory, we should use the appropriate number type for our requirement. In case we don't know, then it's always safer to use the largest, which is decimal at the cost of memory. For example, your variable will just contain the numbers from 1 to 10. Then, needless to say, we can use byte. We can use long, but if you will look at the size, every variable declaration will consume 8 bytes versus the 1 byte that we have for the byte data type. And then we have the decimal, which is a number that can store fractional part. And we have two of them, float and double. By adding e to a float number, we multiply that value to the power of 10. For example, 1e3f is equal to 1000. E means 10 to the third power. 10 times 10 times 10 equals 1000, or 3 zeros. Then we have 1 here. So 1 times 1000 is equal to 1000. And then we have the Booleans. It's the simplest type of primitive data, as it can only hold either true or false value. And finally, we have the char. It is used to store a single character. The character must be surrounded by a single quote. For example, single quote, C single quote. Alternatively, we can use ASCII decimal value to display a certain character. Example, A is 97. Let's see this link of Unicode characters. This is A, and it has a decimal value of 97. Later in this exercise, we will print 97 and we will see that it will print the character A. Now let's look at some code and see how we declare and use the primitive data types. This is a class that I have pushed in GitHub, and it is available in this URL. github.com/Czetsuya/java-programming-for-beginner, which I will add in the description box of this video. Now let's look at my example. This is for primitive data type, and this is how we declare the primitive data type. So byte b equals to 1, short s equals 1, int I equals 1, and then when declaring a long, we can append an L to the number. If we remove the L, it will be accepted, but it's a standard to add or to suffix the number with L, so that it will cast that number to long. And then we have float, where we append F and then we append D for double. By default, when we have a decimal number like this one, 1.0, it will automatically cast the value to double. So there's really no need to add a suffix D, but for standard purposes, let's add D. And this is the one that is required, the suffix F, because if we remove the F, 1.0 will be automatically converted to double. And if we look at the error, we have a type mismatch, cannot convert from double to float. That's why we need to explicitly tell the compiler that this is a float number. And then for Boolean, we have true. For character, we have C. And let's try running this class. Again, to run this class, we can press Ctrl F11. Primitive data type, and we should have some output here. So here are the variables that we have printed. This is the first set, and then we have the default values. These default values are set in the class level. As we can observe here, we have defined these variables or these primitive data types, but we haven't really set them. But if we look at the log, we can see that B1 is 0, and then most of the numeric data types are set to 0, default to 0, and then Boolean is set to false, and character is set to null. And that is what we have here in the table. So these are the default values. Again, moving on, this is an example of float declaration using the scientific number, float fs1e3f. Again, if we look at the log, it prints 1000 because it's 10 to the third power, which is 1000 times 1 equals 1000. And then I will demonstrate that if we declare a variable in the constructor or the method level and we did not assign it to any value, then it will throw a compile time issue like this one. B6, the local variable B6 may not have been initialized because B6 is declared inside a constructor. Again, declaring a variable inside a constructor or method and not initializing it and using it in any statement will throw this error, uninitialized. May not have been initialized error. But when we do or when we declare a variable, an uninitialized variable in the class level, then it will be set to the default value. Moving on, let's see some overflow here. Now remember that byte can only hold values from -128 to 127. So if we try to set a value longer than that or bigger than that, then it will throw this error. Cannot convert from int to byte. And then it's the same with short. Cannot convert from int to short. And the same with int and long. Now, these last two sets of statements are about setting a variable more than the value that it can actually hold. For example, if we already set this i3 variable to the max value and then we add 1, so what will happen is it will rotate to the negative part of that range. So let's check. So let's run again. Let's run the primitive data type class. Here we can see that the maximum value of int is this number 214748367, and then when we add 1, we will notice that the value becomes a negative number because there is no 648. So it will rotate to the negative value, which is negative 214,748,3648, and that is the same when dealing with the minimum value. So if we set I4 to the minimum value and then we subtract 1, so it will move to the largest positive value. Again, so we have the minimum value, which is 648, and then if we subtract 1, then the value will rotate to the maximum positive value, which is this value that is printed here. Now let's move on to the reference data type. Data types that refer to objects. Note that the 8 primitive data types each has their own equivalent reference type. And then autoboxing, the ability to automatically convert a primitive data type into a reference data type. For example, integer x equals to 10. Integer is actually the wrapper class for int. Let's check some example declarations here. These are for non-primitive data types. Let's check this one first. Integer x equals to 10. And what did we said when we first discussed about the reference data type is that we can call some methods, we can perform some operations with the object. And here we have x that, say, we can perform some comparison, we can convert it to the byte value, and we can convert it to short value to string, we can divide it. So again, to see what operations we can perform to an object, we can declare a variable of that type of object. For example, integer x equals to 10. And then let's type x that. If we are using Eclipse, then we should see this method. So this is called IntelliSense, where it shows the methods that we can invoke from a certain object. Now let's run this class and see how reference data type works. Here we have two ways of declaring a string. Remember that because I remember taking an exam about how many ways you can declare a string. And number one is you can use a constructor, and number two is you can assign a string directly to a string variable. Now, what about this? If we look at line 16, this is normally how you will declare an object in Java. You use the new operation. So it means it will allocate a new instance of that variable in the heap memory with the value hello world. So if we look at the console log here, we can see that it prints the hello world 1 from str1, hello world 2 from str2, and it prints null in the str, which is the string variable that we have declared at the top of this class. Again, declaring a string inside a constructor, this is called a constructor, or inside a method, and using it in a statement will cause a compilation issue. The local variable str3 may not have been initialized. And to demonstrate the autoboxing, here I have integer x equals to 10, and then I print the value x, which prints 10 int. And for references, here is the actual Oracle documentation about primitive data types, which you might want to read if you wanted to know more about the primitive data types. And that's it for this video. I hope you like it. Please do like my video and subscribe to my channel so that when I upload the next one, you will be the first one to know. Goodbye and thank you for watching.